So we're going to solve and graph and then write in set builder notation and interval notation. Okay, so if I solve this, I get x is less than negative 10. So I'm going to do set builder notation, x such that x is less than negative 10, negative infinity to negative 10, not including negative 10. So I'm going to put negative 10, negative 11, negative 12, negative 9, negative 8, negative 7, open dot, and it's going less than. This one does not equal, so I subtract 5. 3x is not equal to negative 3, so x is not equal to negative 1. Set builder. And then negative infinity to negative 1, union negative 1 to positive infinity, not including negative 1. 0, 1, 2, 3, negative 2, negative 3. So open dot and everything except for negative 1. This one right here, I add 7 to both sides. I get 2x is less than or equal to 18. So x is less than or equal to 9. So set builder, negative infinity to 9, including 9. So I come here, 9, 10, 11, 12, 7, 6, 5. And that says all the things less than. So it's all the stuff down here. Okay, next. 5x, subtract 6, cannot equal negative 10, so x cannot equal negative 2. So, oh, that was horrible. Such that x cannot equal negative 2. So, negative infinity to negative 2, union negative 2 to positive infinity, not including negative 2. So negative 2, negative 1, 0, 1, 2, negative 3, negative 4, negative 5. So everything in each direction except for the number negative 2. So negative 3x minus 12 is less than or equal to 6. Add 12. Negative 3x is less than or equal to 18. X is greater than or equal to negative 6. X such that x is greater than or equal to negative 6. So that means closed to positive infinity. 6, 7, 8, 9, 10, 5, 4, 3, 2, 1. Oh, negative 6. Negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, negative 7, negative 8, negative 9, negative 10, negative 11, open dot, or closed dot, and it's all the numbers greater than. So this next one, negative 8 less than 3x minus 3 minus 5. Negative 8 is less than 3x minus 8, which is less than 10. Add 8. That will get me 0 is less than 3x, which is less than 18. Divide by 3 and get 0 is less than x, which is less than 6. So set builder notation. Interval notation. So negative 1, 0, 1, 2, 3, 4, 5, 6, 7. And it goes from 0 to 6 and all the stuff in between. Next, add 9. X is less than or equal to negative 6, or divide by 4 and get x is greater than 7. So I'm going to go by 2's maybe. 2, 4, 6, 8, 10, negative 2, negative 4, negative 6, 8, negative 10. It's less than or equal to and greater than 7. So x is less than or equal to negative 6, or x is greater than 7. So there you have it. Okay, over here I'm going to add 4. That was funny looking. 11 is less than x, which is less than or equal to 1. This would be no solution because 11 will never be less than 1. If I'm going to have interval notation, in set builder notation, that's what it would look like. Okay, over here, add 1. I have negative 4 is less than or equal to 2x, which is less than 8. Divide by 2. Negative 2 is less than or equal to x, which is less than 4. Set builder. Interval. So 0, 1, 2, 3, 4, and negative 1, negative 2, and all the stuff in between. Note, on this one, no solution. Notice how I didn't graph at all. Add 4. X is greater than 2, and I would get 3x is less than or equal to 9, which x is less than or equal to 3. So it's less than 3 and greater than 2. 0, 1, 2, 3, 4. So it's greater than 2 and less than or equal to 3. It is 2 less than x, which is less than or equal to 3. Multiply everything by 2. You get x minus 6 is greater than or equal to 2. So x is greater than or equal to 8. Or x is less than negative 5. Okay, so I think I need to go by 2's again. 2, 4, 6, 8, 10. Negative 2, negative 4, negative 6, 8, negative 10. So it's greater than 8, and it's less than negative 5. So set builder notation, x is greater than or equal to 8. I didn't close that dot. Or x is less than negative 5. And set builder, interval, okay. So I'm going to subtract 2 on each one of these. I get negative 2 is less than 4x, which is less than or equal to 12. Divide by 4 on each one of these. Negative 1/2 is less than x, which is less than or equal to 3. So set builder, negative 1/2 less than x less than or equal to 3. And interval notation, negative 1/2 and including 3. So 0, 1, nope. 0, 1, 2, 3, negative 1. So this would be negative 1/2. This is 3. So it's the stuff in between. This one, I subtract 6 on both sides. I get negative 2x. It's less than or equal to negative 2. So x is greater than 1, or greater than or equal to 1. And add 3. Get 5x is greater than 10. So x is greater than 2. So this is and. So if I have 1 and it's greater than, and I have 2 and it's greater than, the only part that it's overlapping is this part right here. So 0, 1, 2, 3, 4. So the part that's overlapping is this part. So my answer is x is greater than 2. So, oops, nope. 2 all the way to infinity. Subtract 3 on both sides. I get 2x is greater than 4. X is greater than 2. And 5x is greater than or less than or equal to 10. So x is less than or equal to 2. So this wants the part that's overlapping. So it's this one, we're at 2 and it's going this way. This one's at 2 but not. So there's nothing overlapping, so it's no solution. Add 4. Get x is greater than or equal to 5 and add 2, so I get 3x, or subtract 2, and I get 9, so x is less than or equal to 9. So on here, it's greater than or equal to 5 and, oh no, why am I writing it that way? The lowest number is 5. The highest number is 9. 5 to 9. 0, 1, 2, 3, 4, 5, 7, 8, 9, 10. So it's closed out at 5, closed out at 9, and all the stuff in between. This one I get 4x is less than 8. So x is less than 2, and I get 2x is greater than or equal to negative 4. So x is greater than or equal to negative 2. So it wants and. So the lowest number is negative 2. The highest number is 2. Oh my goodness gracious. There we go. So negative 2 to positive 2. 0, 1, 2, 3, 4, 5. Negative 1, negative 2, negative 3, negative 4, 5. So I have a closed dot here and an open dot here, and it's all the stuff in between. X is less than or equal to 9, or x is greater than 12. 9, 10, 11, 13, 14, 15, 8, 7, 6, 5. It's less than or equal to 9, and it's greater than 12. Less than or equal to 9, or x is greater than 12. So 9 to 12. Ooh. No. This is an or statement. Sorry for Sadie. Sadie, enough. Okay. So I'm going to 3x minus 3 minus 2 less than 13. Negative 2 is less than 3x minus 5. Add 5. And I get 3 is less than 3x, which is less than 18. So 1 is less than x, which is less than 6. So set builder. Oops. Interval. Shh. Can I just say that when you get in the higher grades, that they actually put the parentheses like that? But I know we're not in the older grades. So open dot, open dot. There we go. This one, absolute value, less than. So this has an and in between. So x minus 7 is less than or equal to 3. And x minus 7 is greater than or equal to negative 3. So x is less than or equal to 10. And x is greater than or equal to 4. So the bottom number is 4. The top number is 10. So 0, 1, 2, 3, 4, 5, 6, 7, 9, 10. Close dot, and all the stuff in between. Okay, this one, I add 2. I get n minus 1. The absolute value of it is less than negative 8. Positive less than negative never happens, so the answer is no solution. Okay. Subtract 3 from both sides. Absolute value of n minus 7 is less than 8. So this is an and statement. So n minus 7 is less than 8, and n minus 7 is greater than negative 8. So add 7, add 7. So my low end is negative 1. I'm so used to doing the x that I wrote x instead of n. And so I have negative 1, comma, 15. So what am I going to go by? Let's see, 0, negative 2, 2, 4, 6, 8, 12, 14, 16, 18. So it's 15, negative 1, and all the stuff in between. Here we go. Subtract 1 from both sides. The absolute value of x minus 8 over 4 greater than or equal to 1. Multiply by 4 on both sides. Absolute value of x minus 8 is greater than or equal to 4. So greater. So x minus 8 is greater than or equal to 4, or x minus 8 is less than or equal to negative 4. So 8 is greater than or equal to 12, or x is less than or equal to positive 4. So let's see, 8, 9, 10, 11, 12, 13. So it's greater than or equal to here. 7, 6, 5, or 3, less than or equal to down here. So x such that x is less than or equal to 4, or x is greater than or equal to 12. And then negative infinity to 4, including 4, including 12, up to positive infinity. Okay, divide by 8, and I get an absolute value of x minus 3 is greater than or equal to 0. Greater, so x minus 3 is greater than or equal to 0, and x minus 3 is less than or equal to 0. So x is greater than or equal to 3, or x is less than or equal to 3. Okay, so 3, 4, 5, 6, 2, 1, 0. If I do less, this is an or statement. If I do greater than or equal to 3, and I do less than or equal to 3, look at what happens. It's all the numbers. So x such that negative infinity to x to positive infinity. So negative infinity to positive infinity. Okay, number 24. Divide by 2, I get x minus 5 is less than or equal to 6, less than x minus 5 less than or equal to 6, x minus 5 greater than or equal to negative 6. So I get x is less than or equal to 11, and x is greater than or equal to negative 1. So the smallest number here is negative 1, and the biggest number here is 11. So it goes from negative 1 to 11, including both negative 1 and 11. So negative 2, 0, 2, 4, 6, 8, 10, 12, 14. So it goes from 11 to negative 1, and it's all the information in between. Divide by 3, and I get 5. It's greater, so 2x plus 3 is greater than 5, and 2x plus 3 is less than negative 5, so 2x is greater than 2, x is greater than 1, or 2x is less than negative 8, so x is less than negative 4. X such that x is less than negative 4, or x is greater than 1. So negative infinity to negative 4, union 1 to positive infinity. So negative 6, negative 5, negative 4, negative 3, 2, negative 1, 0, 1, 2, 3, 4. At positive 1, it's going up and above. At negative 4, it's going down and below. Okay, and divide by 4, get x plus 4 is less than 5, less than. So x plus 4 is less than 5. X plus 4 is greater than negative 5. So x is less than 1, and x is greater than negative 9. Okay, so the lowest number is negative 9. The highest number is 1. Zero, 2, negative 2, negative 4, negative 6, negative 10, 2, 4, 6, 8, 10. It goes from negative 9 to positive 1, and all the stuff in between. Divide by 5. Greater than or equal to 8. Greater, so 3x minus 2 is greater than or equal to 8. 3x minus 2 is less than or equal to negative 8. 3x is greater than or equal to 10. Is that right? Yep. X is greater than or equal to 10 thirds, or 3x is less than or equal to negative 6. So x is less than or equal to negative 2. Okay, set builder. X is greater than or equal to 10/3, or X is less than or equal to -2. So 0, -1. Yeah, I'll do it this way. So 1, 2, 3. Okay, so it's greater than here, and it's, oh, I should, less than here. So -infinity to -2, including union 10/3 to positive infinity. Okay, subtract 4 from both sides, divide by 6 on both sides. Positive less than a negative, never, so no solution. Okay, this next one, I add 8 to both sides. I divide by 2 on both sides. Greater, so 2x plus 6 is greater than or equal to 0. 2x plus 6 is less than or equal to 0. So 2x is greater than or equal to -6. X is greater than or equal to -3, or 2x is less than or equal to -6, and x is less than or equal to -3. This is an or statement, so it's actually all real numbers. So -infinity to positive infinity. So that's everything on here. Okay. Divide by 7, get x minus 7 absolute value of that, and get -2. A positive less than or equal to a negative is no solution. So that is empty set. 4x plus 1 in absolute values is less than -3. Why do I have 2 of these right in a row? I should have had this as a negative, but I didn't. Okay, gonna Do you know the answer already? Because we've done 3 of these. Should have done less than or equal to on this one. So 5x minus 2 is greater than or equal to 0, or 5x minus 2 is less than or equal to 0. So 5x is greater than or equal to 2. 2. X is greater than or equal to 2/5, or 5x is less than or equal to 2. X is less than or equal to, so again, all real numbers. So -infinity to positive infinity, and it's all the numbers on the number line. Okay, Shauna solved the math problem below and wrote her answer in interval notation. Is Shauna's answer correct? Okay, so added 3, that looks good. divided by -7. Change the inequality. So it's, if I was to graph this is an OR statement. So I'm at 0, 1, 2, 3. I'm going this, open dotting it here. Then I'm at -2, and I'm going here. So since it's an OR statement, it's all of this, since it's OR. So actually, it should be -infinity to 3. Tracy was really hot at our softball practice. She yelled, "It has to be at least 110 degrees outside." 110 degrees. Let X equal the temperature. Okay? At least has to be greater than or equal to 110. The football team is selling raffle tickets to motivate the students to buy tickets. They're giving a discount to anyone who is under 18. They also want to give a discount to anyone over 60. Specify, let X equal the age. So, for people who have a discount, so people from ages 0 to 18 are going to have a discount. Well, that was weird. Or people 60 and above. So I'm going to write first, specify a variable, then write and graph an inequality. Okay. So 0 is less 18, or X is greater than or equal to 60. Zero, let's see, 10, 20, 30, 40, 50, 60, 70, 80. So 60 and above, and 18 to 0.